right. Today we're just going to talk about a few different ways to represent functions. Last time we talked about exactly what is a function, and just a basic review idea. A function takes a value from the domain, such as x, and you map it to a value in the codomain. So if I have domain, let's say I have 1, 2, and 3 in this, then I have a codomain, and this is, we can call this x, we can call this y, I don't know, maybe this has 4, this has 8, this has 12 in it. And then we would say this and that and this sort of mapping, this is the function f of x. And that's kind of what's going on. And the function is typically defined, like you don't have to, I mean, sometimes you'll have to you'll get these two and then you'll have to figure out the function, but typically you'll get a function, you'll get the domain, and then you can using that information, you can create or map the codomain. And so the question today is representing these functions. There's just a few basic ways. I'm just gonna go over it real quickly. I'm trying out a new format, obviously. Hopefully this works a little bit better. All right. Yes, representations of functions. So there's many useful ways to think about functions, and we're gonna take a look at just a few. There are more than I'm gonna show you. The one everyone knows, you've got the graph. So in the first video, we were talking about this sort of number line, x to y. That is exactly what the graph is. It's a xy plane, but this is essentially a number line that goes on for infinity, and this is a number line that goes on to infinity. And what we're doing whenever you're plotting on a graph is you take a value on the x, and then you plot it to the y, if that makes sense. So, for example, let's say we have, great. Let's say we have the function f of x is equal to x squared. And remember, this is the same as y equals x squared. So what we could do is take any value of x. So x, negative infinity to positive infinity here. Maybe I should put arrows here to convey that. We pick any value of x, so let's say we pick 2, right? And then we're gonna plot it to the y. So let's plug 2 in, so f of 2 is equal to 2 squared, which is equal to 4. So at 2, we go 1, 2, 3, 4, and we get a coordinate pair, 2, 4, x, y, 2, 4. If that makes sense. Graphs, very elementary idea, so yeah, but if we want to look at the function itself, this is a big idea. If we want to see what x squared looks like, then we're going to want to plot several of these values to sort of get an idea. And the more values we establish, the more points that we have, the better idea of a curve we can have. Right now, I don't know what the curve looks like with only 1 point. But f of 1 is equal to 1 squared, which equals 1. So at 1, we've got 1, right? F of 0 is equal to 0 squared equals 0. We get this, right? And then f of negative 1 squared, which equals 1. And then f of negative 2 equals negative 2 squared, which equals 4. And you can do a whole bunch of points in between there. It doesn't have to be integers. You could have 2.5 or something like that. but eventually you'll see that the shape of f of x equals x squared is this. We call this a parabola. We might talk about that more in depth later. All right, and then we have we have the table. And this is useful for looking at values themselves, and it can also be useful for figuring out the graph. So and there's no shame in using a table. Like, tables are very useful. I use them frequently. They're just great to get like sort of a quick idea of what values you have, as well as maybe a sort of intuition for what's happening between the domain and the codomain. So it's also helpful for like if you have to find out what the function is. So tables, very customizable. Whatever you need really is what you can make it. But a typical table, like in this circumstance, we'll just stick to this. I personally start with x, and then you could f of x, which is equal to y. Right. And then you just have like -2, -1, 0, 1, 2, all of these values on the x. And then you just plug it into f of x. So f of -2, 4, 1, 0, 1, 4. Voila. Again, these are super basic ideas. I'm taking it slow so I can just get a feel for the format and for teaching, and just try to be clear with things, lay the foundations. And then the final way that I'm going to show to represent functions is simply the equation or the expression. Sometimes it's called like a mathematical expression. It means the same thing. Again, f of x is some function that has x as an input and y as an output. And I just got like a few examples here. So, we have f of x equals x squared. We have, now, it doesn't always have to be x. It can be anything. We could say g of x is equal to the square root of x. We could say h of x is equal to x plus 7. Hell, we could say like star of x is equal to x plus 2 over x. I don't know, something fun. Like, that's that. And there's this thing called composition of functions, which you should definitely make sure you get a hold of. I'm not going to go over it like too in depth, but basically you can compose functions. So let's say we have a function f of x equals x squared, and we have a function g of x is equal to x plus 1, right? Well, we can compose these functions in different ways. So we can say f of g of x, and this would simply, so f of x equals x squared. So x is just like a placeholder. So really we take g of x squared. F of g of x means g of x squared, which is x plus 1 squared. Vice versa, you could say g of f of x, which is equal to f of x plus 1, which is equal to x squared plus 1. These are also represented differently sometimes. So this is sometimes, I'm not a fan of this notation, but it's pretty popular. They'll do like this, like that's supposed to mean like of, but they'll say like f of g of x or like fog x. Similarly, you'll have like this for that. I hope that wasn't too crazy. I hope that makes sense. I hope that's helpful. Feel free to leave any comments or ask any questions. And I might redo these videos, to be honest. I'm just kind of trying to get a feel for it before I really dig in. And I'd like to, at some point within the next month or so, get like a study schedule going, whether that's weekly or bi-weekly or something like that. All right.